Hello, welcome to the Bakwas channel for self-paced tutorials on Raspberry Pi. This video is part of the series of presentations on the CamJam EduKit 3 robot. Glad to have you with us. This particular video provides an introductory demonstration on running the motors of the robot. There are two key objectives for this demonstration. First, test the DC motor operations individually. Second, rotate each motor separately in clockwise and anti-clockwise directions. Demonstration assumes that the robot has been previously assembled. While the demonstration code uses GPIO functions explicitly, please note that this method has been superseded by the developers of the CamJam EduKit 3 robot. Their current repository is available at GitHub. There are two key prerequisites for the demonstration. One, the hardware accessory on top, also known as HAT, has been installed. And secondly, the auxiliary battery is fully charged. The code development can be done in many ways. For example, one could use a text editor like Nano, or a more sophisticated visual integrated development environment, IDE, like Genie, or maybe some other more popular ones like VS Code. For illustration purposes, the code uses helper functions to abstract the motor operations. We have shown a very simple way of abstraction, and of course there are opportunities for more complexity. The initialization of the GPIO pins take place inside the helper functions, and there are functions to rotate both motors in forward and reverse directions. Run the program from the terminal window by changing to the working directory where the Python program is located. Then invoke the Python interpreter, Python 3, with the name of the file. In this case, it's hellomotors.py. The library files for the EduKit 3 can be downloaded from their GitHub site. Change to the working directory and type git clone space followed by the URL for the GitHub repository, and the files will be downloaded into a local folder under your current working directory. You can use the directory listing ls commands in its various formats to examine the files that have been downloaded. Let us now review the code by launching an IDE, Genie, and look at the source code line by line. This example is called hellomotors.py, and it is a very, very simple way to examine the operations of the two motors in the robot. Motor A is the right motor, motor B is the left motor. There are no special libraries needed. We are going to be using the GPIO functions to enable the forward and reverse motions. First of all, we need to assign the GPIO pins. As you can see, we've assigned 7, 8, 9, and 10 as the pins for the motors in their individual modes. We've also defined a basic helper function called a class motor, and we instantiate a motor object by defining the left and right motors that way, and we pass the parameters for the forward pin and the reverse pin in each instantiation. The parameters are saved for the object during the initialization phase, and thereafter the functions reverse, forward, for stop and go are individually defined as simple settings of the GPIO pin. We just enable the pins to high and low, and the advantage of this is we don't have to memorize the pin numbers, and we define the pin numbers in one section of the code, and thereafter we can reference it by mnemonic, similar to using variables in programs. To enable a mode, the pin has to be set to high, and to disable that mode, the pin is set to low. So forward or reverse, if we want the movement, we set the pin to high, and if we want to stop that operation, we set the pin to low. We can stop both motors as a precautionary measure, and we set both pins in that case to low. The code is pretty much straight sequential. We first do a movement for the left motor, and then we do a movement for the right motor. So we start with the reverse operation, let it run for a second, and we stop it, then we go for the forward motion, and we run it for 1 second, and we stop, and we repeat the exercise on the other motor. Simple extensions to the program should be considered. One, to run both motors concurrently, and then to perform turn operations.